In the previous video, we understood how JavaScript actually runs under the hood by exploring the runtime environment and core components of a JavaScript engine. In this one, we will visualize the synchronous behavior of JavaScript by executing a simple code example to see how all of those components work together to make your code run. So let's start. Before we move forward, let's understand a few terms that we will be consistently using during this video. Number 1, execution context. When the JavaScript engine scans your code, it makes an environment within itself called the execution context that handles the entire transformation and execution of the code. Consider it as a container that holds all the necessary information for the currently running code. Now, during the execution context runtime, two things or phases happen. Number 1, creation phase, where the JavaScript engine creates the context and sets up the environment. The parser parses the source code and allocates memory to the variables and functions which are defined in your code. This process is also known as memory allocation phase. And number 2, execution phase. In this phase, the JavaScript engine executes the source code with a particular execution context. It processes any expressions or logic which you have written in your code and returns back results. Then the next term that we need to know is types of execution context. There are two different types of execution context. Number 1, global, which is created when a JavaScript engine first starts to run your code. This represents the global scope in JavaScript. And number 2, function or local execution context, which is created whenever a block of code like a function is called or invoked. Then we need to know about the components of execution context. Each execution context has two things inside of it. Number 1, the thread of execution. It is the order in which the JavaScript engine executes statements and expressions within an execution context. You may consider it as you're reading a book left to right, word by word, and line by line. This process of taking a line of code, parsing it, and then executing it is what we call the thread of execution. And number 2, a memory of its own. Each execution context has its own memory to store the data of that particular context. For example, the global execution context has a global memory. The function or a local execution context has its local memory. Then we need to know about stack memory. JavaScript engine uses a special kind of memory to keep a track of all execution contexts created within a script. So all execution contexts in your code are stored on a memory called stack memory. It is also called execution context stack or runtime stack. When the JavaScript engine starts executing, the first execution context, which is the global context, is pushed onto the stack. And whenever the thread of execution hits a function invocation, a new execution context is created and then pushed onto the stack. Now how this works is the execution context, which is on the top, will be executed first and return its result. And once it completes its execution, it will be popped out from the stack memory. This tracking principle or pattern is called LIFO, last in, first out. The execution context which comes first will be executed first, and then it will go out first because it is on the top of the stack. So to summarize this process, when you run your JavaScript code at first, these are the series of steps that take place. Number 1, a global execution context is created and pushed on the top of stack, and it starts its execution. Number 2, the global thread of execution starts going through your code and starts parsing it line by line. Number 3, any globally defined variables or functions are stored in the memory within the global execution context. Number 4, as soon as the global thread of execution hits any function call, the JavaScript engine creates a new local or functional level execution context for that particular function and pushes it on top of the stack. Number 5, the locally created execution context has now its own memory and thread of execution. So it starts executing now as it is on the top of the stack. The local thread of execution stores any locally defined variables and functions in the local execution context memory and starts executing the expressions and logics within this function. Once the function is completed its execution, its result is returned to the parent execution context, which is global context in many cases, and then this function context is popped out or removed from the stack. Number 6, the global execution context continues to execute after that function and completes its execution. The global execution context is not removed from the stack as it is a base of execution until and unless the application or program is closed completely. These steps might sound very confusing to you if you're listening to this for the first time or if you're new to this concept. So let's actually grab a simple code snippet and understand how everything is working through that snippet. Alright, so whatever we have learned so far in this video, now we'll try to make sense of it with the help of a simple code snippet. So I'm back into my Miro board screen. We have a very simple snippet here where we have a few variables defined in the start and then a function which just creates full name, and then a function which simply logs out details of the user, and then this function is called. So I want you to consider this arrow that I have here as a thread of execution. So as we have learned so far in the video, whenever JavaScript first sees your code and it starts to execute your code's first line, it makes a global execution context and then pushes that context onto the stack, right? Now we'll try to move the thread of execution line by line to see how JavaScript engine interprets this code, right? Okay, so if we see the first line of code, the thread of execution hits this line and then it says, okay, a constant called first name is defined with the value of Munza. So what it does is it stores this constant into the global memory of the global execution context. So we're going to say first name is Munza. Let me just increase that font size a bit. Right. So now the thread of execution moves to the next line and interprets this line, which says that there's a constant defined as last name whose value is Shah, right? So I'm just going to copy this line over. In the memory, now the thread of execution stores this variable called last name with the value which is defined in the code, right? The next step is the thread of execution moves to the next line where the age constant is defined, and it is a numerical constant. So what it does is it stores the age into the memory as a numerical, which is 27, and then it moves to the next line where it sees the designation as a constant and it stores its value into the memory. So far so good. There is no rocket science in this. What it has done so far is it has seen the variables and then defined them into the memory, and that's all. The thread of execution moves to the next line then, and it encounters a function definition, which is create full name. Now if you see here, this function is not being invoked, it is just being defined. So as we discussed, whenever a function is being defined, what the thread of execution or what the JavaScript engine does is it simply defines that function into the memory, and then the local execution context opens up later on when the function gets invoked. So what it does, it says create full name and takes this function and define this as a function in the memory. So the thread of execution, instead of going into this function because the function is not yet invoked, it jumps on to the next line where another function is defined which says display user details. So it does the same thing with this function. It takes this function and defines this in the memory, display user details. The next line where the thread of execution moves is this, and boom. On this line, it hits a function execution for the display user details. What happens is when the thread of execution, the global thread of execution, hits a function invocation, what happens is the JavaScript engine creates a new local execution context or function execution context and then pushes that execution context on top of the stack memory, right? So let's try to do that. Execution context, which is now created for the function, let me copy this over. This is for the function display user details, and let me give it some other color so that we can differentiate it, right? And now what's happening here is this function is now pushed on top of the stack, and the pointer of stack moves to this function, which means that now this function will be executed first. So now the thread of execution will be changed into a local thread of execution mainly, and then it will move into the definition of this function, which is this line. So now the expressions within that particular function, within this function, are being executed. So what it says full name, print full name, and then print colon, and then give a space, and then this function is being invocated. Now what's happening is, within the display user details function, another function which is called create full name is being invocated, right? So another execution context will be created right in front in this execution context, right? So what we have here right now is a chain of execution context. If you see, we have the global execution context. Inside of the global execution context, we have the display user details function execution context. And within this context, the function create full name was called. So this new execution context is for the function create full name. And let me differentiate its color. Okay. So let me place it here. And now what happens on the stack memory is that there is another function being pushed on top of the stack, which is create full name, right? And the pointer moves to the top of stack, which means it now executes this function first. So now the thread of execution moves here. Sorry, it moves here, where the create full name is being executed, right? So what it does is it simply returns these two variables, the first name and the last name. Now the first name and the last name were already being stored in a global memory, and since these two execution contexts exist within the global memory, which means they have access to these variables, right? So the first name and last name will be used here, and with the help of that, what it does, it simply returns the first name, which was Munza, and then the last name, which was Shah, right? As we have discussed, when a function completes its execution, the execution context gets deleted. Its result is returned to the parent execution context, and the execution context, which is on the top of the stack, gets removed as well. So now the pointer of stack moves back to display user details, where we were before, right? So this basically is the result of running the function create full name, and now the thread of execution moves back to where it was. This line is now executed, so it moves back to the next line, which says just console log the age and convert it to a string. So what it does is it takes the age, let me just copy this over because it's printing almost the same thing except for the fact we have a capital A there. So it takes the age and then it prints it and converts it to a string, right? So it basically does this. So let's move the execution context to the next line, where it displays age and then displays the designation. So I think there's a fault in the code. It should be designation, and then the designation should be printed. So let's just print as it is, whatever it says. So it says age, and then it says software engineer. This looks a bit weird, but yeah, whatever the code says. That's what copy paste does to you. But yeah, whatever. So this is what we have right now. So with that, the thread of execution moves to the last line of our function, and it completes the function execution. Now what happens when a function execution gets completed? The result of that function basically is returned to the parent execution context, and the execution context is deleted from the stack memory, and the pointer of stack moves back to the global execution. So now that the execution is completed, now this line has already been done, so the thread of execution has now completed its execution. And what we have as a result of this code is it prints out my details, my full name, my age, and my designation inside of the global execution context. And the global execution context does not get removed from the memory until and unless I close this application or I close this program from my computer, right? So I hope you've now gotten a good idea of how JavaScript actually works behind the scenes to make your code run, how it plays around with call stack and execution context to execute your code. If you like this video, subscribe us and stay tuned for the next one. Yeah, bye.